Now I introduce the Monte Carlo sampling for policy iteration. For a model-free system, means this P is unknown. Policy iteration can use only Monte Carlo episodic samples to estimate the optimal policy and the optimal action state value function Q. The key step is how can we use Monte Carlo sampling to calculate the return along an episode without the model P information. Let's see this Bellman equation for a Q function. The left-hand side is the Q is the expected return. Now here, this expectation includes two meanings. First, we calculate the return along each episode, and then we calculate the summation of a return over all the possible episodes. Now let's see how we use the Monte Carlo sampling to calculate the return Q and the policy pi for selected action A along an episode from a current point to the terminal without this model information. Let's see this start from in a backward path. This terminal. We first calculate the Q next to the terminal. This Q equal to this summation of this R, real world R, and the state value function at the terminal. Because this R is a function of S prime and A prime. So at this state S prime, we select the action A prime. That means this R is known. And the state value function at the terminal also is known. So we can use this formula to calculate the Q at the S prime and for the selected action A prime. Once we have this Q, then now we can use this formulation to calculate the Q at state A and selected S and selected action A. Step by step, go backward until we reach this point. We get the return. Once we get the return, then we calculate the sum of the return over all the possible episodes. So use the Monte Carlo sampling method, because this one we need the expected return. So if number of episodes tends to infinity, the action state value function Q will converge to the expected return under the policy pi. Then once we know how can we calculate the return and the expected return by using the Monte Carlo sampling, then we can use this policy iteration, repeatedly change the policy evaluation and policy improvement until converging to the maximum, to the optimal policy and the optimal Q function. First, let's see the policy evaluation. We'll first start from arbitrary policy pi 0. Under this pi 0, for each action, we use the Monte Carlo sampling to calculate each return along a single episode. And then we calculate the sum of the return over all the possible episodes. On the one by one, we calculate all the the Q value distribution. That's the policy evaluation. Once we get this Q distribution, then we just see in a greedy way, see which A generated the maximum or generate the maximum Q. And then we use that A as a policy. This, this A is like for the policy improvement. We use this policy in the policy evaluation. We use the Monte Carlo sampling again to calculate the Q distribution. And repeat this procedure until we got the convergent result to get the optimal policy and optimal action state value function Q and the policy pi. So in this way, the policy iteration method only uses the Monte Carlo episodic samples to find the optimal policy and the optimal Q function under the policy pi. For more details, please check with this reference. Thank you. Bye.